Okay, so we come to this quantitative treatment of locus. By that, we mean we want to find the equation, not just a description of the shape of the curve, but the complete equation of the locus, right? Now, once again, we can do it with algebra or geometry. On the left-hand side, I try the algebra approach. The algebra approach, we want to translate this relation into an equation. And we know PA equals to PB. Now, but PA and PB, they are both a square root, so you might as well consider PA squared to be PB squared, alright? So, now it goes like this. PA squared will be like this, alright? And PB squared, once again, the same formula. So PA will be x and y. Point A will be 1 and minus 2, 1 and minus 2. Point P will be again x and y, and B is 7 and 4. Alright, so we expand both left and right hand side. On the left hand side we have x squared and y squared minus 2x plus 4y and 5. Alright, on the left hand side, on the right hand side we have x squared and y squared minus 14x minus 8y and 65. Alright, so the x squared and y squared cancelled, so it's 12x and 12y. Alright, 12x and 12y minus 60 equals to 0. We can divide by 12. X and y minus 5 equals to 0. This is it. Alright, so that is the simplification of we started from PA squared equals to PB squared, so we arrive at this relation between x and y. X and y, they are the coordinates of P, alright. The locus of P means that whichever the x and y, the point P always satisfies this equation, alright. So it turns out to be the straight line. Alternatively, we can do it with geometry, because we know that the locus of P from the qualitative treatment we did previously, right? The locus of P is the perpendicular bisector of A and B, alright? So we just find the perpendicular bisector of A and B using coordinate geometry. First, we need to know the midpoint of AB. And the midpoint of AB is something like this, right? Point A is 1 and minus 2. Point B is 7 and 4. So the midpoint of AB will be at 4, 1. Alright. In addition, we need the slope of L, but before that, we get the slope of AB. Alright. The slope of AB will be 1 and minus 2, 7 and 4. So it is plus 1. Alright. Therefore, because AB and L, they are perpendicular, so the slope of L is minus 1. Using point slope form to get the locus of L, y minus the midpoint, right, 4 and 1, right, equals to the slope minus 1, x minus 4, alright. That is the point slope form. So I guess eventually it simplifies to the same answer, that x plus y minus 5 equals to 0. It is the same answer, right? So either you can do it like the left hand side using algebra, never mind the shape, right? Just follow the equation. Or you look at the right hand side using geometry. Think about the shape of the locus and try to find out the locus, find out the geometric feature of that particular locus. Alright, so one way or another you can attempt this question. So with the similar idea, we want to do another question, right? Once again with algebra and geometric methods. So we have two fixed points, and then the moving point P is moving, so that point P is x and y, alright? So the PA is perpendicular to PB. If PA is perpendicular to PB, we know that the slopes multiply to -1, alright? So now all we need to do is to express these slopes into A and B. So MPA will be 1 and 2, alright? And MPB will be 3 and 4. Okay, so all we need to do now is to simplify this equation. So we have x minus 1, x minus 3, plus y minus 2, y minus 4 is 0. Alright, so that is x squared and y squared minus 4x minus 8y. Sorry, it should be minus 6y. Alright, minus 6y plus 8 and 3 11 equals to 0. Alright, so that is a circle. That's the equation of a circle. But never mind whether it's circle or not, we just follow the idea. PA is perpendicular to PB, and we translate it into something we can calculate and carry on. Alright, but of course, once again, if you know some geometry of this feature, you know that it is the converse of angles in semicircle. Right, so we have point P here, knowing that this is a right angle. Alright, so it is a part of a semicircle, regardless of the position. It is always making a right angle here, and also it's possible that it is on the other side. So we know that the locus of P is the circle with AB as n point of diameter. It's n points of diameter. Right, so we can elaborate from here. We know that the midpoint of AB will therefore be the center. Alright, so the center will be the midpoint of AB, and that goes to calculate midpoint of AB. A is 1, 2, B is 3, 4. So the midpoint of AB is 2 and 3. Alright, this is the midpoint of AB. And also the radius will be half of the length of AB. Alright, so the length of AB will be something like this. Take the square root. Alright, point A is 1 and 2, point B is 3 and 4. So that is the 4 plus 4 square root 8 divided by 2 is square root 2. Alright, so we can have the equation of the circle x minus 2 squared and y minus 3 squared is the square of square root 2. Alright, so this is the standard form of the circle. Now I hope you can check that these two circles, they are the same. Alright, on the right hand side we did it with geometry method. On the left hand side we did it with algebra method, and both methods arise at the same answer. Alright, so this is the end of the part 1.